Hello students, today I am going to introduce the principle of mathematical induction. What is the principle of mathematical induction? First of all, it's a statement. If Pn be the statement such that P1 is true, Pk plus 1 is true whenever Pk is true, then Pn is true for all n belongs to natural number. The principle of mathematical स्टेटमेन्टलाई प्रुफ गर्ने एउटा नयाँ मेथड हो। क्लास 11 को भाइ बहिनीहरुको लागि न्यू कन्सेप्ट छ र एकदमै इम्पोर्टेन्ट छ। त यसका वर्किङ रुल्स तिर हामी जाउँ। नाउ वर्किङ रुल्स, फर्स्ट अफ अल डिनोट द गिवन स्टेटमेन्ट by Pn. The second one, so that the given statement is true for n is equal to 1. That is P1 is true. Third step, assume that the given statement is true for n is equal to k. And 4, so that the statement is true for n is equal to k plus 1 when it is true for n is equal to k. Finally, draw a conclusion that the statement is true for all n belongs to natural numbers. Now take one example. If Pn is the statement, mathematical statement, n cube plus n is divisible by 2, which is given statement, write P1 and P2. Are they true? The solution here, given statement Pn is n cube plus n is divisible by 2. The P1, we need to find P1 and P2. So put n is equal to 1 and n is equal to 2. We have P1. P1 is 1 cube plus 1, which is 2. Similarly, P2, 2 cube plus 2 is equal to 8 plus 2, 10. Both are divisible by 2. So, therefore, both are divisible by 2. So, they are true. We take another example proved by mathematical induction. 1 plus 2 plus 3 plus 4 plus plus n is equal to n times n plus 1 by 2. Its solution, let Pn be the given statement then Pn 1 plus 2 plus 3 plus 4 plus plus n is equal to n times n plus 1 divided by 2. When n is equal to 1, n is equal to 1, the left hand side, we take t1 from 1 plus 2 plus 3 plus 4 plus dot dot plus n. Left hand side we take t1, which is 1. Similarly, right hand side, put n is equal to 1 in right hand side. 1 times 1 plus 1 divided by 2, which is again 1. Our left hand side is 1, right hand side is 1. So left hand side is equal to right hand side. That is, P1 is true. Therefore, left hand side is equal to right hand side. That is, P1 is true. If we take n is equal to 2, then left hand side becomes 1 plus 2. Similarly, put n is equal to 2 in right hand side. Now assume that pk is true for k belongs to n. Continue. Pk 1 plus 2 plus 3 plus plus k is equal to k times k plus 1 divided by 2. Question I. Now we shall show that the theorem is true for n is equal to k plus 1. We shall show that the theorem is true for n is equal to k plus 1 whenever theorem is true for n is equal to k. That is, pk plus 1 is true whenever pk is true. तो यो हामीले सपोज गरेका छौं, यसको आधारमा k plus 1 को लागि यो ट्रू देखाउँछौं. For this, p k plus 1 1 plus 2 plus 3 plus plus k. Pk, here pk, the 1 plus 2 plus 3 plus plus k. The k is replaced by k plus 1. The next term will be k plus 1. In last term, if we replace k by k plus 1, then we get next term. And this is the 1 plus 2 plus 3 plus plus k. This is from I, which is k times k plus 1 divided by 2 plus the next term k plus 1. Here k plus 1 is common. The k by 2 plus 1, and this is k plus 1, the k plus 2 divided by 2, and this is k plus 1, the k plus 1 plus 1 whole upon 2. If we replace n by k plus 1 in right hand side in given statement, then result is n times n plus 1 by 2. This shows that pk plus 1 is true whenever pk is true. Hence, by the principle of mathematical induction, Pn is true for all n belongs to natural number. We take another example. 2 plus 4 plus 6 plus plus 2n is equal to n times n plus 1. Its solution. Let Pn be the given statement, then Pn such that 2 plus 4 plus 6 plus plus 2n is equal to n times n plus 1. When n is equal to 1, the left hand side, our T1 is 2. So left hand side becomes 2. The right hand side, put n is equal to right hand side. The 1 plus 1, which is again 2. Therefore, left hand side is equal to right hand side. That is, P1 is true. Assume that Pk is true for n is equal to k belongs to n. That is, Pk such that the 2 plus 4 plus 6 plus plus 2k is equal to k times k plus 1. Question I. Now we shall show that the pk plus 1 is true whenever pk is true. For this, P k plus 1 such that 2 plus 4 plus 6 plus plus 2k, the next term k plus 1, the k is replaced by k plus 1, then we get next term, the 2 and k is replaced by k plus 1. And this is 2 plus 4 plus 6 plus plus 2k, the 2 times of k plus 1. By equation I, this is k times k plus 1 plus 2 times of k plus 1. Here k plus 1 is common, k plus 2 and k plus 1, k plus 2 can be written as k plus 1 plus 1. Suppose k plus 1 as n, then it becomes n times n plus 1. Given statement को right hand side में n times n plus 1 छ, यदि त्यसमा k plus 1 राखिदिने भने यही रिजल्ट आउँछ. This shows that pk plus 1 is true whenever pk is true. Hence, by the principle of mathematical induction, Pn is true for all n belongs to natural number. We take another example. Prove by induction method 2 plus 5 plus 8 plus plus n terms is equal to n times 3n plus 1 divided by 2. Here the last term is not given. So first of all we find its nth term. Solution. Nth term of 2, 5, 8 is a plus n minus 1 times d. A plus n minus 1 times d, because 2, 5, 8 are in AP. A plus n minus 1 times d. This is 2 plus n minus 1 times, here t2 minus t1, 5 minus 2 is 3. So this is 2 plus 3n minus 3. This is 3n minus 1. Now let Pn be the given statement. Then Pn such that the 2 plus 5 plus 8 plus the n terms, that is 3n minus 1. 3n minus 1 is equal to n times 3n plus 1 divided by 2. When n is equal to 1, the left hand side we take t1, this is 2. The right hand side put n is equal to 1, right hand side. The 1, 3 into 1 plus 1 divided by 2. The 3 plus 1, 4 divided by 2, 2. The left hand side is equal to right hand side. Therefore, left hand side is equal to right hand side. That is, P1 is true. Now continue. Assume that Pk is true for k belongs to natural number. That is 2 plus 5 plus 8 plus plus 3k minus 1. 3k minus 1 is equal to k times 3k plus 1 divided by 2. Now we shall show that Pk plus 1 is true whenever Pk is true. For this, Pk plus 1, the Pk plus 1 such that plus 5 plus 8 plus dot 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 plus 3k minus 1 is equal to, sorry, the 2 plus 5 plus 8 plus dot 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 plus 3k minus 1. If we put k is equal to k plus 1 in last term, then we get next term, because here is k plus 1. The 3 times of k plus 1 minus 1. The pk plus 1 को लागि सुरुमा त्यो लेफ्ट ह्यान्ड साइडलाई कपी गर्ने। अब नेक्स्ट टर्म लेख्नको लागि धेरै स्टुडेन्टलाई प्रब्लम हुन्छ, त त्यति बेला के गर्छौं, यसैलाई कपी गर्ने, के को ठाउँमा k plus 1 नेक्स्ट टर्म आइहाल्यो। Now from equation I, the 2 plus 5 plus 8 plus dot 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 3k minus 1, this is k times 3k plus 1 divided by 2. K times 3k plus 1 divided by 2 plus here 3k plus 3 minus 1. This is 3k square plus k divided by 2 plus 3k plus 2. Taking LCM, 3k square plus k plus 6k plus 4 divided by 2, and this is 3k square plus 7k plus 4 divided by 2. This is 3k square, and here 7k is 3k plus 4k. 3k plus 4k plus 4 divided by 2. 3k is common. 3k is common. The k plus 1 plus here 4 is common. K plus 1 divided by 2. K plus 1 is again common. 3k plus 4 divided by 2. The k plus 1 and here 3k plus 4 can be written as 3 times of k plus 1 plus 1 divided by 2. लास्ट मा गएर स्टुडेन्टलाई कहाँ इन गर्ने त्यहाँ प्रब्लम हुन सक्छ। सो हाम्रो प्रब्लम स्टेटमेन्टमा हेर्ने, जस्ट n को ठाउँमा k plus 1, 3 को 3, n को ठाउँमा k plus 1 plus 1 divided by 2. This shows that p k plus 1 is true whenever pk is true. Hence, the principle of mathematical induction, Pn is true for all n belongs to natural number. We take another example. First of all, let Pn be the given statement. Then Pn such that 1 cube plus 2 cube plus 3 cube plus dot 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 plus n cube is equal to n square times n plus 1 whole square divided by 4. Sum of cubes of first n natural number. When n is equal to 1, the left hand side which is 1 cube, it's 1. Right hand side, put n is equal to 1, right hand side, 1 square 1 plus 1 whole square divided by 4, which is again 1. Therefore, left hand side is equal to right hand side. That is, P1 is true. P1 is true. Assume that Pk is true for k belongs to n. That is, Pk such that here n is replaced by k, then we get 1 cube, 2 cube, 3 cube plus dot 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 plus k cube is equal to k square, k plus 1 whole square divided by 4. We shall show that Pk plus 1 is true whenever Pk is true. Now, we shall show that Pk plus 1 is true whenever Pk is true. For this, Pk plus 1, 1 cube, 2 cube plus 3 cube plus k cube plus k plus 1 whole cube. And this is 1 cube plus 2 cube plus 3 cube plus dot 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 k cube is equal to k square times k plus 1 whole square divided by 4 by our assumption. K square, k plus 1 whole square divided by 4. This is plus k plus 1 whole cube. This is, here k plus 1 is common, then k plus 1 square, k square divided by 4 plus k plus 1. K plus 1 whole square, k square plus 4k plus 4 whole upon 4. This is k plus 1 whole square, k plus 2 whole square divided by 4. The k plus 1 whole square and k plus 2 can be written as k plus 1 whole square divided by 4. लास्ट में राइट हैंड साइड को जुन गिवन स्टेटमेंट छ त्यसमा n को ठाउँमा k plus 1 राख्दा यो रिजल्ट आउँछ. This showed that P k plus 1 is true whenever Pk is true. Hence, Pn is true for all n belongs to natural numbers. We take another example. Solution. Let Pn be the given statement. Then Pn 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus plus 1 upon n into n plus 1 is equal to n upon n plus 1. When n is equal to 1, the left hand side 1 upon 2, which is 1 upon 2. The right hand side, for right hand side, put n is equal to 1 in n upon n plus 1. We get 1 plus 1 upon 1 plus 1, which is 1 upon 2. Therefore, left hand side is equal to right hand side. That is, P1 is true. Assume that Pk is true for k belongs to natural number. That is, Pk one upon 1 into 2, 1 upon 2 into 3, 1 upon 3 into 4 plus plus 1 upon k into k plus 1 is equal to k upon k plus 1 equation I. Now we shall show that Pk plus 1 is true whenever Pk is true. Now we shall show that Pk plus 1 is true whenever Pk is true. For this, we have Pk plus 1, 1 upon 1 into 2, plus 1 upon 2 into 3, plus 1 upon 3 into 4, plus plus 1 upon k into k plus 1. And next term, for next term, if we replace k by k plus 1, then we get next term. यो k को ठाउँमा k plus 1 राख्ने, यो k को ठाउँमा k plus 1 राख्ने. धेरै स्टुडेन्टलाई नेक्स्ट टर्म राख्नलाई प्रब्लम हुन्छ. अलिकति याद गरौँ. अगाडिको एक्जाम्पलमा नि मैले क्लियर गरेको छु. Now it becomes 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon k plus 1 by equation I. This is k upon k plus 1 plus 1 upon k plus 1 to k plus 2. And this is the k plus 1 k plus 2. LCM is k plus 1 into k plus 2. The k times k plus 2 plus k plus just 1. And this is k square plus 2k plus 1 divided by k plus 1 k plus 2. And this is k plus 1 whole square divided by k plus 1 to k plus 2. Here k plus 1 square cancel. The k plus 1 upon k plus 2 can be written as k plus 1 plus 1. Suppose k plus 1 as just n, then it becomes n upon n plus 1, which is this shows that p k plus 1 is true whenever pk is true. Hence pn is true for all n belongs to natural number. 2 plus 2 square plus 2 cube plus 2 to the power n is equal to 2 times of 2 to the power n minus 1. First of all, let pn be the given statement. Then pn such that the 2 plus 2 square plus 2 cube plus 2 to the power n is equal to 2 times of 2 to the power n minus 1. When n is equal to 1, left hand side, we have left hand side is 2, right hand side. For right hand side, put n is equal to 2 in this expression. 2 to the power 1 minus 1. 2 minus 1, 1 into 2, this is 2. Therefore, left hand side is equal to right hand side. That is, P1 is true. Assume that P k is true. That is, pk such that 2 plus 2 square 2 cube plus plus 2 to the power k. 2 to the power k is equal to 2 into 2 to the power k minus 1. Question I. Now, we shall show that pk plus 1 is true whenever pk is true. For this, pk plus 1, the 2 plus 2 square plus 2 cube plus plus 2 to the power k. For the next term, if we replace k by k plus 1 in the last term, we get next term. And this is the 2 plus 2 to the power 2 square plus 2 cube plus 2 to the power k. This is 2 times of 2 to the power k minus 1 by equation I plus 2 to the power k plus 1. This is 2 to the power, here 2 to the power 1, 2 to the power k. This is k plus 1 minus 2 plus 2 to the power k plus 1. Here the 2 to the power k plus 1 plus 2 to the power k plus 1. The 2 times of 2 to the power k plus 1 minus 2. 2 is common and 2 to the power k plus 1 minus 1. गिवन स्टेटमेंट को राइट हैंड साइड में n को ठाम में k plus 1 राख्दा ठ्याक्क मिलेको छ. This shows that p k plus 1 is true whenever pk is true. Hence, Pn is true for all n belongs to natural numbers. Now, we take another example. Prove by induction method n square plus n is an even number. Let Pn be the given statement. Then Pn such that n square plus n is an even number. When n is equal to 1, P1. So 1 square plus 1, which is 2, which is an even number. Which is an even number. That is, P1 is true. Assume that P k is true. That is, Pk such that k square plus k is an even number. Equation I. Now we shall show that Pk plus 1 is true whenever Pk is true. For this, Pk plus 1, the k plus 1 whole square plus k plus 1. This is k square plus 2k plus 1 plus k plus 1. K square plus k plus 2k plus 2. The k square plus k plus 2 times of k plus 1. Here we arrange k square plus k square plus k, 2k, the 1 plus 1, 2. तो k square plus k किन राख्यो? Question 1 में हामीले बनाएको छौं. K square plus k is an even number. The k plus 1 को multiple 2 छ. यो पनि हाम्रो even number, which is an even number. As k square plus k is an even by equation I, and clearly 2 times of k plus 1 is an even number. तो दुईवटा even number को sum even number. This shows that P k plus 1 is true whenever Pk is true. Hence, Pn is an even number, for all n belongs to natural numbers. Another example, n cube plus 2n is divisible by 3. First of all, let Pn be the given statement. Then Pn such that n cube plus 2n is divisible by 3. When n is equal to 1, P1 1 cube plus 2 into 1, which is 3, which is divisible by 3. That is, P1 is true. Assume that Pk is true. That is, Pk such that k cube plus 2k is divisible by 3. Question I. Now we shall show that Pk plus 1 is true whenever Pk is true. For this, Pk plus 1, k plus 1 cube plus 2 times of k plus 1. This is k cube plus 3k square plus 3k plus 1 plus 2k plus 1. K cube plus 3k square plus 5k plus 2 plus 2 plus 1 is 3. The k cube plus k and 3 k square plus, for this, Pk plus 1, k plus 1 cube plus 2 times of k plus 1. And this is k cube plus 3k square plus 3k plus 1 plus 2k plus 2. The k cube plus 2k plus 3k square plus 3k plus 3, 1 plus 2, 3, 2k, 2k, and this is k cube plus 2k plus 3 is common, then k square plus k plus 1. Here k cube plus 2k is divisible by 3 by I. Similarly, here k square plus k plus 1, coefficient of k square plus k plus 1 is 3, multiple of 3, so it is again divisible by 3, which is 3 as k cube plus 2k is divisible by 3 by I, and clearly 3 times of k square plus k plus 1 is divisible by 3. This shows that pk plus 1 is true whenever pk is true. Hence, Pn is true for all n belongs to natural numbers. We take another example. 3 to the power 2n minus 1 is divisible by 8. Let Pn be the given statement then Pn 3 to the power 2n minus 1 is divisible by 8 when n is equal to 1. We have P1 is 3 to the power 2 into 1 minus 1. 3 square 9 minus 1, which is 8, which is divisible by 8. That is, P1 is true. Assume that Pk is true. That is, Pk such that 3 to the power 2k minus 1 is divisible by 8. Now we shall show that Pk plus 1 is true whenever Pk is true. For this, Pk plus 1 3 to the power 2 k plus 1 minus 1, and this is 3 to the power 2k plus 2 minus 1. 3 to the power 2k into 3 square minus 1. 3 to the power 2k into 9, 3 square. Then minus 1 can be written as minus 9 plus 8. Minus 9 plus 8 minus 1. Here 9 is common. 3 to the power 2k minus 1 plus 8. Here 3 to the power 2k minus 1 is divisible by 8 by I, and 8 is divisible by 8, which is divisible by 8 as 3 to the power 2k minus 1 is divisible by 8, and clearly 8 is divisible by 8. This shows that pk plus 1 is true whenever pk is true. Hence, Pn is true for all n belongs to natural number. Now we take another example. The x to the power n minus y to the power n is divisible by x minus y. Let Pn be the given statement then Pn such that x to the power n minus y to the power n is divisible by x minus y. When n is equal to 1, P1 x to the power 1 minus y to the power 1, which is just x minus 1. Clearly x minus y is divisible by x minus y, which is divisible by x minus y. That is, P1 is true. Assume that Pk is true. That is, Pk x to the power k minus y to the power k is divisible by x minus y I. Now we shall show that P k plus 1 is true whenever Pk is true. For this, Pk plus 1 x to the power k plus 1 minus y to the power k plus 1. We need to show x to the power k plus 1 minus y to the power k plus 1 is divisible by x minus y. Then x to the power k plus 1 minus x into y to the power k plus x into y to the power k minus y to the power k plus 1. Here x to the power x into y to the power k negative, x into y to the power k positive, cancel, then it becomes first line. Here x is common. From first to x is common, then remaining factor x to the power k minus y to the power k plus from last to y to the power k is common. Y to the power k is common, and remaining factor is x minus y. The first term x to the power k minus y to the power k is divisible by x minus y by I, by our assumption. And clearly the second term x minus y is divisible by x minus y, which is divisible by x minus y, as x to the power k minus y to the power k is divisible by x minus y by I, and clearly y to the power k times x minus y is divisible by x minus y. This shows that p k plus 1 is true whenever pk is true. Hence Pn is true for all n belongs to natural numbers.